Hello and welcome to the Rashmi's CLASSESTODAY will discuss on evolution of telecom and introduction to 6G. So let's get started. First generation, 1G, mobile networks were designed for voice services with data rates of up to 2.4 kilobits per second. Analog signals used to transmit information, and there was no universal wireless standard. Second generation, 2G, was based on digital modulation techniques and offered data rates of 50 kilobits per second to 384 kilobits per second, supporting not only voice services but also data services such as short message service, SMS. The flagship 2G standard was the Global System for Mobile (GSM) Communications. Third generation, 3G, mobile networks provided data rates of at least 2 megabits per second and enabled advanced services including web browsing, TV streaming, and video services with data rates of up to 20 megabits per second. To achieve global roaming, 3GPP was established to define technical specifications and mobile standards. Fourth generation, 4G, mobile networks were introduced in the late 2010s. 4G is an entirely Internet Protocol (IP)-based network capable of providing high-speed data rates of up to 1 gigabit per second in downlink and up to 500 megabit per second in uplink to support advanced applications such as digital video broadcasting, DVB, high-definition TV content and video chat. LTE Advanced (LTE-A) has been the dominant 4G standard, integrating technologies such as coordinated multipoint (COM), transmission and reception, multiple input multiple output (MIMO), and orthogonal frequency division multiplexing (OFDM). Fifth generation, 5G, is to use not only the microwave band but also the millimeter wave (MM wave) band for the first time to significantly increase data rates to 20 gigabits per second. Another feature of 5G is the more efficient use of spectrum, as measured by increasing the number of bits per hertz. ITU's International Mobile Telecommunications 2020, IMT 2020, standard proposed the following three major 5G usage scenarios: enhanced mobile broadband, EMBB; ultra-reliable and low-latency communications, URLLC; massive machine-type communications, MMTC. As 5G is entering the commercial deployment phase, research has begun to focus on 6G mobile networks, which are estimated to be deployed by 2030. Typically, next-generation systems do not emerge out of a vacuum, but rather follow industrial and technological trends from previous generations. Potential research directions for 6G in line with these trends were provided by 2019, which included, among others, sixth generation, 6G, is envisioned to provide even faster data speeds, lower latency, greater capacity, and support for advanced technologies such as artificial intelligence, virtual reality, augmented reality, and the Internet of Things, IoT. It may also include innovations such as terahertz frequency bands, massive MIMO, multiple input multiple output systems, and advanced antenna techniques to enhance network performance. Filled circle 6G will continue to move to higher frequencies with wider system bandwidth. Given that the spectrum at lower frequencies is nearly exhausted, the current trend is to increase the data rate by more than 10 times for each generation to achieve wider bandwidth at higher frequencies. Filled circle massive MIMO will remain a key technology for 6G. Massive MIMO has been the defining technology for 5G, which has enabled the antenna count to increase from 2 to 64. Given that performance gains have saturated in the areas of the channel coder and modulator, spectral efficiency increases for 6G in the multiple antenna area will continue to be expected. Filled circle 6G will take cloud service to the next level, with consistently higher data rates, lower latency, and lower transmission costs. Many computational and storage functions have been moved from smartphones to the cloud. As a result, most of a smartphone's computational power can be focused on presentation rendering, making VR, AR or XR more efficient and affordable. Many artificial intelligence (AI) services that are intrinsically cloud-based can be more easily and widely proliferated. In addition to smartphones, low-cost functional terminals may once again flourish, providing opportunities for development in more application areas. Filled circle grant-free broadcasts may become more prominent in 6G. In previous cellular network generations, broadcasts were primarily based on grant-oriented designs with strong centralized system control. 6G will require more advanced grant-free protocols and approaches. It is possible that non-orthogonal multiple access (NOMA) technology may have another chance to prevail due to its low latency performance, even if it fails to take off during the 5G time period. Filled circle MMTC is more likely to take shape in the older generation before succeeding in the next generation. MMTC has been one of the major directions for next generation system design since the growth of the people-to-people communication market. High hopes are pinned on 5G MMTC to deliver significant growth for the cellular industry. However, so far, this expectation has been mismatched with reality. Thanks for watching the video. Please like, share and subscribe this channel.